Hi, this is Crystal Bishop with West Virginia State University, NASA SEMAA. Today we are following up with our kite activities, and we're going to make a windsock and an apparatus that we can use in conjunction with the windsock. So these are the materials that we're going to need. We are going to need 2 pieces of paper, one measuring 8.5 by 11 inches, another one approximately 11 by 11 inches. We'll need tape, scissors, a ruler, a single hole punch, 2 paper clips. We'll need kite string. And then we're going to need something to attach our windsock to. So we can use a rod, a broom or a mop handle, some sort of base maybe to attach the broom and the mop handle to. If we take it outside, we're going to also need a compass so we can determine wind direction. If we are going to use this inside, then we need some sort of apparatus to blow air. So maybe a fan, a dryer, or a blower. Also, if we use this inside, we may want to use a tape measure and some duct tape. Also, I have found with my students that when we're tracking wind direction, speed, and then we are comparing it to what type of breeze it is, that we can use a protractor device to help us know what that is. So let's go ahead and get started. First of all, we just need a plain sheet of paper. And basically what we're doing is we want to fold it in 2/3. Now you can eyeball it or you can actually measure it out. Basically 2.8 inches is 2.9 is about right. So now that we have folded that, the next thing we're going to do is take a piece of clear tape, and we're going to tape the end of this, and we're going to let about half of our tape hang off of it, because what's going to happen is we're going to fold this over and we're going to overlap this by a 1/4 of an inch is fine, and that'll take this down to 8 inches. Because we're losing a 1/4 and overlap on this edge and this edge. So we've taped it, but we need to tape it a little bit more securely. Now you can use your clear tape, gift tape, scotch tape, what have you. I prefer just to get a bit of packing tape. Again, it just makes it a little easier on me when I'm doing this, but generally if we have a lot of students that day, we just use our scotch tape, and we just make sure the inside and the outside is taped up. So now we have that. So we've got a tube, and it's just very simple. Now we have to do the body of the windsock. So we want it to look like this. This is a finished windsock. Now, in the NASA activities, it tells you to use tissue paper, which is what this is. I find with my younger students, the paper's just too thin. It rips too easily, and I found that Christmas paper works rather well. However, you can take copy paper, construction paper. You just don't want to be using a thick paper because it weights the windsock down and it can give you false readings. So what I've done here is I've just taken 2 sheets of copy paper. One was colored, one wasn't, and I butted them up together, and then I took clear tape along the length of it and wrapped so they were then attached. And again, I didn't overlap it, I just literally butt it together. Then what I did is I began measuring. First I need 28 centimeters on this side, or approximately 11 inches, and I made a mark here, and I did the same thing on this side. When I was finished with that, I then connected the 2 marks and drew a line. Then what I did was I measured 4 centimeters from this line to here, and I did that on the inside, right here and right here. And then again I lined those marks up and I drew a line. Then I came down a little further and then every 3 centimeters I drew another mark. And you'll notice on one edge of the paper you'll have 4 centimeters instead of 3, and that's okay because you're gonna there could be some overlap, so it's all right that it's not every section is perfectly 3 centimeters. The end section probably won't be. So then I did the same thing down here. When I completed that, I began cutting this apart. So I'll go ahead and continue cutting. Until I get my job finished, I will cut each of these. Once I get all of these cut, what I'm going to do is cut off the excess of that pink paper, and I'll put it in my used paper box. That way when we're working on other, that came off, when we are working on other STEM projects and we need just scraps of paper for whatever reasons, then we can get in that box and use that. So now I've got all of these strips cut. I don't want to cut them out, I just want to cut them apart. Now the other thing that I'm going to do is I'm going to cut the excess, like I was saying earlier, off right through here. Alright, again I'm going to save that, put it to the side. I'm going to do like what I did with the tube. I'm just going to take a piece of tape and I'm going to tape half of this. And I'm going to actually line this line up with the edge of my tube, and I'm going to just tape that down. And then I'm going to wrap this around my tube. Okay, and I'm going to make sure my lines meet, and I'm going to tape that down as well. Now that I've just got it taped down, I want to make sure it's adhered well, so I'm going to take some tape down through here. Then I'm going to take some tape all the way through here, all the way around. So for me, I'm just going to go ahead and use this packing tape for that, but again, you can just use normal tape. Now the NASA activity actually says to glue it, and there's nothing wrong with gluing it. If you have the time in your class to do that, by all means. We have, with regards to what we do here at WVSU NASA SEMAA, you know, every moment's precious, so where we can take a shortcut, we do. So now that we have this part put together to this extent, we need to punch 3 holes. So what we're going to do is punch a hole on one side, and then we're going to look at it as though it were a triangle. And we're going to want to punch a hole right in here and right in here, because we want as much as possible an equal distance between the holes. So you could also theoretically, when you've got this tube laid out, measure it in thirds, so you'll have an approximate idea where your holes are going to be laid. Or, like I said, we needed 4 feet of string cut. So here is 1, 2, and then we need 2 more of those. Oops. So I can just use my string to measure my other string. And do it one more time. Okay, now what I want to do is I can tie this string or I can tape it. In my other ones I have, normally I tape, but as you can see I can simply just tie a knot and make sure it's tightened as much as I can. Notice that I take the string on the inside. That's just habit, particularly if you tape these down. You'll find that it's easier if the string is more pointed towards the inside than the outside. So again, I'm just going to tape that down, or not tape it down, tie it down as tightly as I can. And then I'm going to do that one more time. And again, you can tape it. It's just however you want to do it. You can granny knot it. You can do a slip knot. Just you know, whatever is most convenient for you and your participants, depending on their grade, age, ability, motor skills, that sort of thing. So now I want to pull this kind of taut and get an idea of where this is going to be. So now I want to tie this around a large paper clip, which I have in my box over here. And now I'm just going to tie it. Again, I can granny knot it, slip knot it. I can tape it if I wanted to the paper clip after I tied a knot. So I've got my knot tied. And that's a pretty thick knot. Okay, and I've tightened it down as much as I can. Now, this part of my windsock is ready. What I will end up doing is taking a broom handle, and I've got a base that I put it in, and I tape a paper clip to the top of my broom handle. That way, what I can do is tie the fourth piece of string to it and attach another paper clip at the bottom, so when I take my windsock, I can just attach the two paper clipped ends. And then where I'm testing inside, if I want to test a kite instead of a windsock, I can just unpaper clip the windsock from my test handle and then hook up a kite to that. So again, like I said, I just take this fourth piece and I tie the paper clip to it. And then, like I said, I have a paper clip on the other end for which I tape onto the handle or the rod. In my case, it's a broom handle. And when I tape it up, I don't want to tape the string up on the broom handle. I just want the paper clip done that way. But I realize that a lot of people do not have broom handles sitting around. So what I would suggest is maybe a meter stick instead, and then you can hold or somehow affix the meter stick to an area that it's not going to fall down. So as you can see here, saying this was a meter stick, you just tape your paper clip and see how this string is really still able to move. And then you tape, or I'm sorry, you stick your paper clip through, and now it's secure. So when the wind is then going through, or the air fluid is going through this, it's attached. And then when you don't want to use the windsock, you simply unattach the two paper clips. And like I said, at this point you can then take one of your template kite models or another kite model and use this same apparatus to hang that off of, and use your hair dryer, the kite tunnels to test. Now, another thing that I do, and I have one on my broom handle, but as I said, if this were a meter stick instead of a ruler, you know, this would work as well. I would like to use a protractor. In the NASA activity, they give you there's a worksheet that describes what a strong or a slight breeze or a strong breeze looks like. What I did is I went back in on this particular handout, and I added a protractor in degrees because I think it's easier for students to learn how to judge what calm or slight or what have you is, are rather, if they can see a metric to compare it by. So we added this stuff into it. So what we do is at the top of our rod or our broom stick handle or our meter stick is that we put a protractor, but I have since learned that it's probably a good idea to collar it and collar code it and then put a legend in it. So what I've learned to do is take things like manila folders that we're no longer using and cut out a protractor template, or you can do construction paper, cardstock, what have you. You can actually, I've even used the protractor and just taken permanent marker and collared the protractor. But what I normally do is I take the protractor, use it as my template, and I take a pen and I line it all out, and then I write the information that I want. I want to know that a calm breeze is 60 to 90 degrees at 0 to 3 miles per hour. I want to know a slight breeze is 40 to 60 degrees and it represents 4 to 7 miles per hour, so forth and so on. So what I do is I go ahead, once I have completed my template, and I cut it out. Now I could maybe take laminate and laminate this and then just put it up. But normally, because I do have such a healthy supply of protractors, I usually just use this in tandem with a protractor. But again, it's not necessary. If you're not borrowing inventory from us, work with what you have, recycle and resource to the best of your ability. So what I do is I simply take my Scotch tape or my packing tape and I tape my protractor and this information together, and then I adhere it to my broomstick. And like I said, we've used meter sticks in the past. It's just, again, whatever you have available to you. So, and when I did mine this way, I took packing tape and I just wrapped the whole thing. And in the past, we've also done laminate. So, say again, instead of this being a ruler, it was a metric stick, I would just simply adhere my handy dandy protractor. You could use sticky side double stick tape. In my case, because I do have mine on a broom handle, all I did was, you know, just do a crisscross on the tape to the handle, and that worked out rather well, and it's been through a lot of testing, and it's been very durable. So I've crisscrossed this, and I'm going to crisscross it one more time just to make sure it's holding down as well as it is able. Okay, so Now I have my protractor. So when the wind blows, or the airflow blows from the fan or the dryer or what have you, this is going to pull out, and this is going to tell me if it's in the black, it's calm. If it's in the orange, it's slight. If it's in the green, it's gentle. If it's in the blue, it's moderate. And if it's in the red, it's a strong breeze and it's a no-fly zone. So this is a really easy way of making a device for your Windsock that helps your students identify what type of breeze, what the degree of that is in comparison to the stick or the rod or the ruler, and then what that represents in miles per hour. Now if I take this outside, I'm going to want to attach a compass to it. So normally what I would do is lay the compass directions out. Either I would put some type of template manila folder or something like that listing north, south, east, west. But normally what I've been doing of late is just taking a large compass that we've been purchasing and sticky taping it or gluing it on the base wherever the meter stick is, and then pointing it north. So if this were north, I would be turning it this way, because I want my Windsock, if it was due north, it's going to blow north. So that concludes how to put a Windsock together, and a little bit about the Protractor. If you want to learn more about how to about the broom handle apparatus and how this works and how to test the Windsock, then please pull up the Windsock test video. Again, my name is Crystal Bishop. I'm with West Virginia State University NASA SEMAA, and thank you for joining us today.